This is the first video of 2 for a review on factoring. In this video, I'm going to talk about the greatest common factor, or GCF, and grouping. And just for your reference, we're going to be factoring things that look like this. So let's get started. As a reminder, I do have guided notes to go along with this. So you might want to have the guided notes next to you, just so that you can kind of follow along, and then you can stop and do some of the examples when needed. So let's first start by just reviewing what it means to be the GCF. So I think it's best to actually just show you an example of this, and we'll just talk about it. So let's say I've got 5x plus 5y. Just by looking at this, what do these two terms have in common? Well, clearly it's the 5, right? And so that's what would be known as the GCF. So if I wanted to actually factor this, I bring that thing that they have in common out in front, and then I basically divide it out of the other two terms. So this would be what 5x plus 5y looks like when it's factored. So that's kind of the idea behind the GCF. So the greatest common factor, it's the largest factor that can be divided out of all terms. So let's just take a look at a few other examples of this, building off of that first idea. So what if I had the example 5x plus 10y? What do those two factors have in common? Well, it's still the 5, right? So if I wanted to divide now 5 out of 5x plus 10y, well, now you just go term by term. So dividing the 5 out of this part here, that's just going to leave me with the x. And then dividing 5 from 10y, now I'm left with 2y. That's because 10 divided by 5 is 2, and then nothing happens to the y. So that would be what this looks like in its factored form. So now let me add on to this a little bit. What about if we have 5x squared plus 10xy? Now you might want to pause the video here and think about this for a second. What is the GCF here? Pause if you need to. The GCF is now 5x. So take a look at this, right? This has 5x squared, and this is 10xy. So both terms have an x in them, and the smallest amount of x's that they have is just this one singular x. So now I have to divide this out, right? So if I divide 5x squared by 5x, what am I left with? Just one singular x. And then if I divide out 5x from here, what am I left with? Well, still 2y. Okay, so let's keep going with this idea. So now let's say that I've got 5x plus 5. What's the GCF here? Well, now it would be just 5, and if I were to divide that out, this is going to leave me with x plus 1. So here's a tip for you. Sometimes when people are factoring out the GCF, if the GCF actually is one of your terms, then 5 divided by 5 is just 1. So sometimes people will do this and they will just drop the term entirely, or they might think that it's a 0. The thing that you want to keep in mind is, so if you start with 2 terms here, then in the parentheses, you still need to have 2 terms here. So that's kind of a hint if you're like prone to thinking, oh, it's a 0. That's a really common mistake. So you just want to remind yourself, you still need 2 terms here, so this must be a 1. So that's just kind of a quick sanity check. Okay, so let's just try one more, still building off of this example. So now let's say that I've got 15xy squared plus 25x cubed y to the 5th. Again, you might want to pause the video here just to see if you can figure out the GCF. So here, the GCF is going to be 5x y squared. So how did I know that? Well, 5 clearly divides 15 and 25 for sure, right? Now, look at these two terms. They both have x's and y's in them, right? So now what you're really looking for is, what is the lowest amount of x's and y's between the two terms? So in general, what you can do when you're factoring, you can always just kind of look and choose the letter kind of with the lowest number on it, I guess. So if I were to factor this out now, what am I left with? Well, this is going to be 3 plus 5x squared y cubed. And so that would be that in its factored form. So this is kind of the basic idea now behind the GCF. So now what I want you to do is try the next few examples on your own. So here are two. Go ahead and work them out, pause the video, and then we'll go through them together. So for example A, the GCF here would be 5y. So looking across at all the terms, all three definitely have a y in them, and then all three are definitely divisible by 5. So if I factor out the GCF, this is going to be 3x plus 5z minus 7. Now, for b, what would the GCF here be? Well, that's going to be 4x squared y to the third. So again, the way that you figure that out is, so notice that all three terms, they all have an x and a y. So then what you're looking for is just what is that lowest exponent. So in this case, this would be the lowest exponent on the x's, and this would be the lowest exponent on the y's. So you can always kind of bank on that. And now it's just a matter of kind of dividing this out. Now, if you're rusty on this, when you divide exponents, what you're really doing is you are subtracting you're subtracting the two exponents from one another. So let's go through this. I've got 12 divided by 4, that's going to be 3. Then I've got x squared divided by x squared, so the x's actually drop out. And then y to the fifth divided by y to the third, I just subtract the exponents. So 5 minus 3 is going to leave me with 2, so I'm going to write 3y squared here. Okay, so the rest of this answer then, this is going to be 4x to the fifth, and then plus 8, oops, sorry, not 8, 6, my bad, 6x y to the fourth. Okay, so let's move on to the next example. Once again, pause the video here and just make sure that you've got it. So if I were to factor out the GCF here, this is going to be 7, just 7y to the fourth, it looks like, right? So looking across at all of these, so notice not all of these have an x or a z, but they all do have a y. So that's kind of the key thing that you're looking for. So now if I factor this out, I'm going to be left with 2x cubed y minus 3 y to the third, z to the third, plus x squared. And so that's it for that one. Okay, so now let's do D. So the GCF in this case, well, notice when you look at all the numbers, there's actually no number that will divide 15, 9, and 20 all together, right? So we can't factor out a number. Then when I'm looking across at this, so let's see, we don't have x's in all three terms, we don't have y's in all three terms, and we don't have z's in all three terms. So actually there is no GCF. So this is actually prime, is what the term is, so it can't be factored. So trick question in this case. Okay, now let's move on to grouping. So with grouping, there's always kind of a classic example to kind of help explain the idea. So let's say that I want to factor now ax plus ay plus bx plus by. So take a good look at this. Notice that there's no GCF for the entirety of this example. There's nothing you can come up with that you can factor out of all four terms. So that is usually a cue that you want to use grouping. Also, a lot of times what happens with grouping is that you actually have four terms. So sometimes that can be a cue to use grouping. Now, one thing that you might notice about this is that even though there's no one singular GCF, it's almost like there's many GCFs in these like clusters. So here, what is the GCF between these two terms? Well, it would be the A, right? So that's the GCF there. And then in the second two terms, what would it be here? Well, it would be the B. So with grouping, this is actually kind of what we notice and where we start. We factor out the A from the first two terms, and if I factor out the A from the first two terms, this leaves me with x plus y. And then from the second two terms, I will factor out that b. And if I factor out the b from the second two terms, that also leaves me with the x plus the y. Now, take a look at what we've got. I've factored this out. So now I kind of have like this term here, and I have this term here. Terms are usually broken up by like a plus sign, so that's usually what makes something a term. So if I look at this and this, now what do these two things have in common? Well, actually now the GCF of these two terms would be the x plus y. Alternatively, the way that you can think about this is if you have the same thing in the parentheses here, this is what allows you to group them. So all I have to do now is write out that x plus y, and then I just write out what's in front of the set of parentheses. So that's going to be this a plus b. Now, I can write this in one of two ways. I can either write it in this order, or I could write it as a plus b times x plus y. It doesn't matter which way that you want to go with this. It's the same thing. Usually I actually write it in this way. So this is the idea behind grouping. You kind of do this mini GCF type thing, and then if you have the same thing in each set of parentheses, then you can kind of factor that out, and you just write what's in front of the parentheses. So let's take a look at another example. So let's say that I've got 3x plus 3y minus xz minus yz. So this has a very similar flow like the other one that we just looked at. So in the first two terms, they both have a 3 in common, and in the second two terms, they both have a z in common. So it can be either a number or a letter or both that they have in common, so you just want to stay kind of sharp with this. So one more time, if I factor this out, so I bring the 3 out in front, and I'm left with x plus y here. Now be careful with these other two terms. So notice that these are both negative, so I don't want to factor out just z. I actually want to factor out negative z. Because if I factor out the negative z, then that's going to leave me with, this will become positive x and this will become positive y. So when I factor that out, I'm left with x plus y like this. And so once again, I have that kind of relationship that I'm looking for, where I have the same thing in both sets of parentheses. So if I finish factoring this then, this will be 3 minus z times x plus y. Or, like we said, x plus y times 3 minus z. I will usually write it actually in this order, but if you prefer to write it in this order, that's okay too. Okay, so this is kind of the gist of what we're doing. So now let's practice this skill a little bit more. The first thing that I want to do is actually just kind of get you used to finishing the final step of factoring. So where we're going to start with this is examples that look like this. So I have set up the grouping for you, and I just want you to finish it. So notice in this example that I have x minus 2y and x minus 2y. So that's what I need to finish the grouping. So we just want to finish it by taking what's kind of in front of the sets of parentheses and then writing out what that other set of parentheses is that they have in common. So this is kind of where I want to start, just to kind of get you warmed up on this idea. So on your own, go ahead and pause the video and do these on your own. Okay, so for b, if I just write what's in front of the set of parentheses, this is going to be 3x minus 2z, and then x plus 5y. Then for c, this is going to be 4xz minus 5xy times 3t minus 1. So again, I'm just taking exactly what's in front of the parentheses, including whether this is a plus sign or a minus sign, and then I'm just writing it directly in here. Okay, so let's take a look at two more examples just to make sure that we've got it. So go ahead and pause and try these on your own if you need to. And this is going to be 9z minus 2 and x plus 3y, or you could have 9z minus 2 and 3y plus x. So in this case, these are the same, right? X plus 3y and 3y plus x are the same. It doesn't matter which way that you want to write this. You just want to kind of recognize, like, if you were going very quickly with this, you might think, oh, x plus 3y and 3y plus x. So it's not the same thing. So you just have to kind of think about it sometimes if that actually makes sense. Then as far as e goes, so you just want to think about what is the invisible number that is in front of the parentheses right here. Well, this would actually be a -1 here. You just kind of have to know that, right? So this will ultimately end up factoring 4y minus 1 and 3x plus 1. And okay, so that kind of wraps up that set of exercises. So now what I want to do is I want to work on the full-blown grouping example. So maybe you want to just pause the video here and now see if you can put all the steps together. So very similar to what we just talked about, right? So we've got the 3's here in common and then the z's here in common. So this will factor 3 times x plus y plus z times x plus y. And then this looks very similar to the other exercises that we did. So this becomes 3 plus z times x plus y. So those are all the steps that we want to put together now. So now you can try the next examples on your own. So go ahead and pause the video and just try these and make sure that you got them. So for b, I'm going to factor out 5xy. And so then that's going to leave me with 1 plus 2x. And then in the kind of the second group, I'm going to factor out -3, and that's going to leave me with 1 plus 2x. So then I can write this as 5xy minus 3 and 1 plus 2x. And there we go, I'm done. Now for c, with the first two terms, what do these two have in common? Well, this would be 5x to the third, and if I factor that out, I'm going to be left with 3x minus 2. And then in the second two terms, so this will be plus 3x, and then that's going to leave me with 3x minus 2 again. And so then I can finish this. This will be 5x cubed plus 3x, and then 3x minus 2. Now, you might have actually done this in a slightly different way, or you might notice something at this point. So look at this piece of the factorization here. So this factor, what do you notice about it? There's actually a GCF here. And if you go back to the original problem, you might actually notice in re-inspecting this that there was a GCF in this step as well. So if you did this at first, that's great. If you didn't notice it, I'm just showing you what you could do now. So if I look at this term, 5x cubed plus 3x, these both have an x in common, so I can actually factor that GCF out. So I'm going to factor that out, and then what am I left with? This would now become 5x squared plus 3. So this would be the true factorization and the true final answer for this problem. So sometimes you might notice a GCF right out of the gate, and then you can just factor it out in front and then continue on with the problem. Sometimes you might not until the very end, and so then this is what you would do. Now let's go ahead and do the next two examples. So once again, you can pause the video here and then play whenever you're ready. So out of the first two terms, I'm going to factor out 6xy, and so then that's going to leave me with 2x minus 1. And then out of the second two terms, I'm going to factor out 5, and that's going to leave me with 2x minus 1. Now be really careful when you do this with the second two terms. So clearly the second two terms have a 5 in common, but when you factor out -5, that's actually going to reverse your signs, right? So factoring -5 out of here is what makes this positive 2x in here, and factoring -5 out of here will flip this sign to negative. That's a really common error to make. Now, we can finish the factoring from here. This will be 6xy minus 5 and 2x minus 1. All right, so now E is actually a little bit trickier here. So let's start by first factoring out what we see in common. So in the first two terms, they both have a 3 in common. So this is going to be 5x squared plus 2y. And then in the second two terms, well, it looks like they only have an x in common. So if I factor that out, I'm left with 10y plus 9. Now, in looking at this, you might think, okay, well, now there's a problem here. She's trying to trick me. This and this is not the same in the parentheses, so it must be prime. And sometimes that's true, but sometimes that's not. So this doesn't work, but look at the problem one more time. What would happen if we were to rewrite this? You have to just make a guess as to what would be the best way to do that. So let's say that I want to put the two terms that have y's together and then the two terms that just have x's together. Let's see if that changes anything. So I'm going to rewrite this as 15x squared plus 9x plus 6y plus 10xy. Okay. So now if I do this, in the first two terms, I'm going to factor out 3x, and that's going to leave me with 5x plus 3. And then in the second two terms, looks like I can factor out what? 2y, and then that's going to leave me with 3 plus 5x. And now, would you look at that? This actually can be factored, right? So now the final answer here will be 3x plus 2y times 5x plus 3. So sometimes this will happen, and you just kind of have to play around with it to see if you can do it. So sometimes if you rearrange the terms, it might actually be able to be grouped. Sometimes it won't. So it's kind of something you just have to kind of experiment with. But this one could totally be grouped. Okay, so one more example here. So once again, you can go ahead and pause the video and play when you're ready. So you might notice here that there actually is a GCF, and so you can factor that out right away if you want. So I'm going to do that in this case. So I'm going to factor out the 5. So then I'm left with x cubed plus 2x squared plus x plus 2. So from here, what do? Well, now you can really just ignore this 5 for a second and just focus on this and just do your traditional grouping. So what do these two terms have in common here? Well, they both have x squared in common. So I would factor out the x squared, and that would leave me with x plus 2 here. And then what do these two terms have in common? Well, really nothing, right? But this is x plus 2, and that's actually what's in the parentheses here. So what would be the best way to kind of represent that? Well, you could just write x plus 2, and now you can see that they have it in common, and you know that there's kind of this invisible 1 in here. So you have to kind of play around with this a little bit. Now, also keep in mind, what do you do with this 5? Well, the 5 is just coming along for the ride now in this problem. So I could write like maybe another set of brackets here and just put the 5 here. This is just kind of coming along. The thing that we care about at the moment is trying to finish this factoring here. So don't let that throw you off. So now if I wanted to finish this, this is going to be x squared plus 1 times x plus 2, and then at the very front we still have that 5. So that would be how that one works. So that one's a little bit trickier. That's definitely a good one to kind of play around with. But the hint here was this was x plus 2 and this was also x plus 2, so that was kind of how you know you were going in the right direction still. Okay, so that covers kind of everything that we've got for GCF and grouping. And so if you feel good with this, then you can move on to the next video.